Okay. Good morning, grade 9. We did not have our homeroom today simply because you came into my class 8:29. I only have Rabi a while ago, and I think it's we're getting late, so we need to start. Okay. Hopefully by next meeting we can have the homeroom and discuss some matters about what we have happening during our foundation day and so on. By the way, let me remind everybody about your video for the foundation day, the one that I had discussed, the TikTok video, Rabi. You start collecting videos from your classmates and compile it in order for us to submit it.
Deadline.
Deadline, let me check on my calendar. Okay. Let's have that one on the 30th, next week. March 30, Rabi. Would that be okay? How about others?
I think
Okay, since the foundation day is in the 5th, so we still have time to give it to Ma'am Irene and compile. Same with the other class. Would that be okay, Rabi?
no, sir.
Okay. So let's continue with Science 9. Okay. We are now down to the 4th quarter. This is the last quarter in this school year. We have module 1 for the 4th quarter, weeks 1 to 4. So this is good for 1 month, okay, 4 weeks, plus, okay, plus our output for this school year. Okay, I'm still thinking about the output for this school year. You can also give suggestion if you have in your mind. Just let me know. Okay. It should be, again, take note that the output should be related to the topic. Okay. So our topic for this module is heat, work, efficiency, and electricity. I actually simplified this one. There are a lot of computations under this module, but then again, I remove all of those. I only included those important details that will be enhancing your skills, enhancing your capabilities and abilities with the said topic. Okay, let's move to heat, work, efficiency, and electricity. So heat and work. What's the heat and work? Okay, if there is heat, tendency is work is done. Okay, if there is heat also, there is a transfer of energy, correct? Okay, so heat is created because there is what? There is movement of particles, number one. Number two, there is a transfer of energy since the law of thermodynamics is telling us about energy cannot be created nor destroyed, but it can be transformed from one form to another. Since it can be transformed from one form to another, meaning to say that this energy can be transferred. Okay? There is a transformation and there is a transfer of energy. Okay? Let's tackle more about this in the middle. The internal energy is the total energy of molecules contained in an object or a system. That's the internal energy. Like for example, in my balloon, okay, the internal energy is the totality, what is inside the balloon and what covers the balloon. That's the total energy or internal energy. Okay, what is contained in the system or in my cup of tea, what is contained there is the total or the internal energy. Usually we term them as total energy or internal energy. When an object gets in contact with another object with a different temperature, okay, energy will transfer from the object with higher temperature to an object with a lower temperature until they reach a common temperature or thermal equilibrium. Okay, this is just the same um with the container. Like for example, if you're going to have a test tube, we didn't actually have the experiment here with regards to osmosis. Okay, from greater concentration, okay, from greater concentration from higher temp, okay, the higher temp will transfer its energy or thermal energy going to the lower temperature or lower temp until it reaches equilibrium or equal temperature. That's the point there. Okay, that's how energy or heat is actually transferred. Okay, from higher concentration to lower concentration until it reaches equilibrium. This is really good if we have face-to-face because we have a lot of experiments that we can actually perform. And of course, you can actually see it in yourself that there is, okay, there is heat transfer or thermal transfer until it reaches equilibrium or equal temperature. Both of the object will actually experience the same temperature. Do you have any questions so far? Questions so
None, sir.
far? Okay. This energy that travels from one object to another because differences in temperature called heat. So this is now heat. Okay. Again, this is the way heat is being transferred, the way heat travels. Okay. From greater concentration, greater heat, to lower concentration, lower heat, until it reaches its equilibrium or equal heat. Heat may be transferred in three different ways. There are three different ways of heat transfer. Number one, this is by conduction or atomic collision. Conduct. Okay, conduction or atomic collisions. That's the first. Like for example, this is into solids. When I get contact with, when I touches, okay, a hot surface, okay, heat is being transferred in my hand. What else? When you heat stones, okay, you transfer heat into the stone. So that's conduction, okay. How about convection? By convection or fluid movement, that's the second thing. Like when you heat hot water, this is by convection, okay? Because you're actually transferring heat to a fluid or liquid. How about by radiation or electromagnetic waves? Okay? When you expose yourself under the heat of the sun, that's the common. So you are actually what? The heat from the sun transferred to you by radiation. Okay? The electromagnetic waves or spectrum. Do you have any questions so far?
None, sir.
Okay. Mechanical work indicates the amount of energy transferred by a force that acts on an object to a distance. Mechanical force, okay? Or mechanical work. Okay, let's take a look at the very detail. Every time heat is transferred, mechanical work may be done. And every time mechanical work is done, heat is produced. So when you say mechanical work, this is actually through a movement. Okay, there is a movement that actually happening there. Just like when you actually use your engines. When there is mechanical work, again, there is what? Heat. Heat is produced. Sometimes also, this engine needs heat in order to work. So they are what? They are directly proportional. When you say directly proportional, when there is work, or when there is mechanical work, there is heat. When there is heat, there is mechanical work. Okay. Heat engines. Okay. Talking about heat engines, they're actually used in old times, and even now we have thermal engines. So they're actually working because there is heat. In the absence of heat, they cannot actually perform its job. Heat engines are devices that change internal energy into mechanical work. Okay. Common types of heat engines include steam, gasoline, and diesel engines. Sure, are they heat engines? Yes, it needs heat. Okay, it needs heat to perform its job, to work. Without heat, they cannot actually work. This is the reason behind that some of the engines needs warm up. That is the reason behind. These engines operate on the idea that mechanical work can be done when heat flows from higher temperature area to a low temperature area. Again, there is a what? A transfer of heat from higher concentration to lower concentration. Okay, high temp to low temp. Okay, this is how actually your engines work. In dealing with heat engines, we talk about two sources. There is two sources in dealing with heat engine. We have the hot and cold sources because again, heat travels from high concentration, higher temp to lower temperature. This is the result. Okay. During this process, heat gains heat from the hot source, which causes an increase in its internal energy. Part of this energy is converted into mechanical work, and the rest is ejected into a cold sink. So if you're going to look at this one, okay, this is the pattern. We have the heat engine. This is the heat reservoir or your um your heat source, and the cold source or cold reservoir in the lower. This is the um heat source and cold source. So if you're going to look at it from heat source, okay, it will actually travel to cold source. Okay. In the process, we are actually creating work. Work will actually correlate with efficiency. How efficient is the work? So these are the formula. But then again, I actually minimize them in order for us also, okay, to adjust on our current situation. Efficiency. If there is work, there should be efficiency. How efficient is that machinery? Okay, machine efficiency indicates how well it transforms heat into useful mechanical work. So there is actually a transfer of or a transfer of heat or transfer of energy. Again, according to the law of thermodynamics, which states that energy cannot be created nor destroyed, but it can be transformed from one form to another. In transforming, again, this energy from one form to another, we created what? We created work. At the same time, we actually converted this energy into another, okay, another useful energy. Okay. It is important to note that no machine or engines in existence works 100% efficiency because some of the transferred heat is transferred into another form of energy. Correct. There is no, okay, even in our present history, even in our present scenario, even in our present time, there is no engine that works 100% of efficiency, 100% efficient. Meaning to say, whatever is converted or transferred will be converted into what? Into work, 100%. No, there's no such thing as 100%. There are some heat or energy that converted into another form. Like for example, if you're going to use your car, okay, you transferred heat, okay, you converted heat into mechanical energy. But how about the sound? You converted also heat into sound waves or sound energy. How about your air condition? Okay, you converted heat into what? Working on your aircon. So those are just few. There is no such thing as 100% efficiency. Okay, because some of this energy will be converted into another form. That's the reason behind. Engine's efficiency or its ability to convert energy into useful work depends on the temperature differences between hot reservoir and cold reservoir. Okay, hot sources and cold sources. Efficiency is represented with a formula. This is the ideal efficiency. Hot reservoir minus cold reservoir or cold temp. Okay, hot temp, cold temp divided by hot temp, okay, times 100. That is actually the ideal efficiency. How efficient is the machinery? How efficient is the transfer of heat? Alternatively, the efficiency of an engine is also a ratio, or the ratio between work done by the system and the amount of heat put into the system. So we can have this one. Efficiency is equal to work done over the heat input times 100. So that's the efficiency. In alternative way, if you're going to look at on the ratio between work, if the question there is asking about work. The higher the machine's efficiency, the greater the amount of heat is converted into useful mechanical work. Okay? Devices with higher efficiency require less energy to operate. So again, commonly, if we have less energy to operate, meaning to say this is what? This is, you can actually just leave it by itself. It's working by itself. Okay? The first law of thermodynamics states that when heat is added to a system, the system does not or does external work and its internal energy increases. This is why no engine in existence works at 100% efficiency. Again, because some of this energy will be converted into another form. Heat engine technologies. Okay, talking about heat engine technologies, heat engines had known as early as the 16th century, but has been made into increasingly useful devices only during the 17th century, when inventors acquired a better understanding of the process or processes involved. They are continually being developed until today. Since then, we actually have the need, okay, of these machineries for advancement of technology, for manufacturing purposes. What else? For economic growth, of course. If we can have these engines, we can create more, okay, more outputs. Here are some of the technological application of heat engines. Okay, geothermal power plants. Are you familiar with geothermal power plants?
Yes.
Okay, geothermal power plants work under the principle of heat engines. Okay, we actually harness the heat from Earth in order for us to convert it into more useful energy using turbines. Okay, these turbines are actually what? Heat engines. It uses energy from the Earth's natural heat in producing electricity to power up houses and industries. This is how geothermal power plant operates using the principle of heat engines. The power plant, okay, digs deep into Earth's surface where the temperature increases in depth and where hot water can be found. Okay, this hot water is pumped to a well under high pressure until it reaches the surface of the Earth, where pressure is then lowered, allowing water to turn into steam. So we have now steam in the process. Okay. The second step is this steam makes the turbine rotate, okay, thereby allowing the generator to produce electricity. So the production of electricity is in the turbine, the one that I'm telling you a while ago. The steam turbine is a device that allows steam to do mechanical work on a generator. A generator, on the other hand, is a device that converts mechanical work into electricity. The cooling tower converts steams back into the water to the low temperature surroundings. So again, you let it cool and return it in the ground. So this is now the layout. Okay, from the hot water reservoir, okay, this is the hot source. It is actually pumped into the steam in order for us to create steam. Okay, and the steam now powers the turbine, which actually connected to a generator, and the generator will supply current in some places. The water will return from the turbine engine, the water will return in the cooling tower. This is the cooling reservoir, okay? Cold reservoir or cold source, and returns back into the ground. And the cycle repeats again and again. This is what we call as what? Renewable resources. Let's continue by next meeting. We are done with geothermal power plants, and hopefully we can discuss more by next meeting. We still have a lot of things to do. We still have a lot of things to discuss. But for now, let's take geothermal power plants first. Okay. Do you have any questions so far?
None, sir.
Okay. Reminding everybody to again submit the needed materials to your teachers, simply because we are now in the middle of finalizing your second quarter grades. And I am in the middle also of recording all your third quarter activities. So hopefully you are done with all of them, because I cannot wait any longer. Inform your classmates that I cannot wait any longer with your outputs for the second quarter and third quarter. Okay. Second quarter, I cannot accept anymore the second quarter. That's our agreement, right? After the exam. So after the exam, I cannot actually accept it any longer. If you have concerns, just let me know so that I can actually assist you with your concerns. Questions so far? Questions?
None, sir.
Okay. I'll be recording your attendance. Hold on. We have Rabbi, Hillary, and Janine. All of your attendance are already recorded. Thank you for cooperating. Thank you for joining the class. Have a nice day, everyone. Enjoy the rest of the day. Bye-bye. Take care.
Bye,
Yes,
sir.
sir.